Okay, good evening, everyone. So here we go. This is the start of our A-level course. We actually will be covering material that you've met before at GCSE for a lot of the first few weeks. So the idea is that we're just refreshing your memory and just ratcheting it up a little bit. And every time I set you some work to do, then there'll be something hopefully which will challenge all of you. So a quick reminder, well, firstly, a quick apology. Bank holiday weekend, been gardening and painting and all sorts, so nails are in particularly bad condition, but they are clean. And also, there's something funny going on with my camera tonight. Don't know why I've got this funny effect, but anyway, hopefully you can see it. So just a reminder about indices rules. We're dealing with indices. I didn't say that, did I? So, when you are multiplying indices with the same base, then you add the index numbers. When you divide indices with the same base, then you subtract the index numbers. And a power of a power, you multiply the index numbers. 4 times 3 is 12. And, that even applies when you're dealing with fractional indices. So a to the power of a half to the power of 5 is 5 times a half, which is 5 over 2, or a to the power of 2.5. And that applies when you have algebra in there as well. The only difference is that we've got coefficients, and those coefficients are not squared or to the power of 5. It's just 5 lots of x squared and 2 lots of x to the power of 5. So I'm going to deal with the coefficients and the algebra separately. So 5 times 2 is 10, always will be. X squared times x to the power of 5 is x to the power of 7. Here, however, we've got 3b squared in a bracket cube. So this time the 3 is cubed as well as the b squared cubed. So just like I did up here, I'm going to deal with the numbers and the algebra separately. 3 cubed, 3 times 3 times 3 is 27. And b squared cubed, well, that's that third indices rule again here, isn't it? So that's going to be 2 times 3, that's going to be b to the power of 6. So when you have numbers and algebra, deal with the numbers and the algebra separately. And we then talked at GCSE about negative and fractional indices. So I'm just going to get you to pause the video at this point and see how many of these you can work through. Okay, so 16 to the power of a half, that's the square root of 16. And if that's not something which is sort of already ingrained in your memory, make a flashcard of it now, stick it on your bathroom wall, all right? Or next to your bed or by your desk or whatever. To the power of a half, it's not half of 16, it's the square root of 16. So 16 to the power of 3 over 2, well, that is 16 to the power of a half cubed. Remember this rule up here? Multiply. So this is this. Now 16 to the power of a half we've just worked out. It's 4. So this thing in the brackets is 4. 4 cubed, 4 times 4 times 4 is 64. And then a negative indice just means the reciprocal of the thing without the negative sign. So 16 to the power of minus 3 over 2 is just 1 over 16 to the power of 3 over 2. To the power of a third means the cube root. So again, if that's not something that's clear in your mind, then put it on a flashcard now. And when you cube root or do a power, any sort of power of a fraction, you can do the numerator and denominator separately. So 8 to the power of a third, the cube root of 8 is 2. And 27 to the power of a third, the cube root of 27 is 3. 2/3, well, that's 1/3 squared. So it's this answer squared. So just like we're going from here to here, that was to the power of a half, this was to the power of a half cubed, this is to the power of a third, this is to the power of a third squared. And then this is exactly the same as this, just with a minus power, so it's the reciprocal, and we could write it as 1 over 4 over 9, but that's the same as just flipping the fraction over. Nearly always easier to work with fractions, so this is the square root of 4/100ths. And just like I do here, I can square root the top and the bottom separately. So 0.2, well done if you got that. And 5 and 1/16, probably easiest to write that as a top-heavy fraction to start with. So 5 whole ones is 80/16. 16/16 is 1 whole 1, 5 whole 1 is 80/16. So this is 81/16. The fourth root, well, we're asking what number to the power of 4 gives me 81, and that's 3. What number to the power of 4 gives me 16? That is 2. Well done if you got those. Okay, so let's take it on a step of difficulty. These two sums look very similar. They're both square roots. One of them we can do really easily, one of them we can't do. It's very tempting to look at this and say, okay, well, a moment ago you said if you cube root or square root a fraction, you can just square root the numerator and the denominator. So it's very tempting to say, right, okay, square root of 9 is 3. Square root of x squared is x, and the square root of 16 is 4. The trouble is that is not correct. And it's not correct because if I went the other way, if I squared this, I wouldn't get this. 4 squared would be 16, but 3 plus x squared, if I grid that out, I don't get this, do I? I get the 9 and I get the x squared, but I also get 6x. So I can't square root that. I mean, I'm okay with the denominator, but actually I would have to just write it as 9 plus x squared to the half over 4. There's nothing better than that I can do at the moment. And that's because you've got two terms on the top here. This is one term. 9x squared is one term, and so ask me to square root that, and it's really easy. Because it's one term, not two terms, I can just say, okay, square root of 9 is 3, square root of x squared is x, square root of 16 is 4. And if you don't believe me, we'll go back the other way, square this. 3x times 3x, yeah, 3 times 3 is 9, x times x is x squared, 4 times 4 is 16. Here, the denominator isn't involved in the power, so I'm just going to write that out again. And it's another one of these ones where I've got two things to the power of 4. So 3 to the power of 4, 3 times 3 times 3 times 3 is 81. And x to the power of half to the power of 4, well, remember the rule, multiply, so 4 times a half is 2, so that's x squared. And final answer, well, no, I can do some simplifying here, can't I? I've got 81 divided by 9, so that simplifies down to 9. X squared divided by x to the power of 1, that's just x to the power of 1, x. Okay, so attached to either class charts or the email are three little clumps of questions that I'd like you to have a go at. And the answers aren't at the end of this video. So it's Tuesday today when I'm going to post this. So I'm going to post answers on Wednesday. And I'm hoping that you'll have a go before having a look at the answers. And could I ask you, if you do have a go on Tuesday or Wednesday before I post the answers, could you just drop me an email with a photo of your answers to the last three? There's three particularly tricky ones. And I'm not doing that because I expect you all to be able to get it right. But I'd just be interested to see how you had a go at it. So, and be absolutely aware, I'm not assessing this. And one thing I definitely need to say is that, you know, this in no way is going to affect any GCSE grade. That's all done and dusted. But no, I'd be really grateful, and that would also give me an idea of who is engaging in this, because if you are engaging in this, you are at such an advantage. So for those of you who I haven't worked with before, my email, well, actually, I think all those I haven't worked with before have been emailing me anyway. But there you go, just in case. I'm mcooper@ilfcomacademy.org.uk. I hope you are safe and well, and please be in touch. And also be in touch if you have any technical issues, anything that's stopping you engaging with this properly, because we can get around any problem, even if it means me posting you, SD cards with the transcripts on or whatever, or the videos on. I'm very happy to work around any technical problems. So please be in touch if you're having any problems. And I hope your calculators are all giving you good service. And I look forward to seeing you all soon. Take care.